All right, today we're going to continue discussing clustering technique that we started in the previous class, right? Clustering technique is an unsupervised learning method. Now let me actually kind of tell you a little bit about clustering, maybe just to clarify things even further. We discussed that clustering exists in the real world, right? And it existed long before data analytics was invented. For example, periodic table is clustering. Zoology or biology, when you classify types, right, and assign animals to certain species, that's also an example of clustering. So there are many different examples in clustering. So how analytics uses clustering? One way to use the analytics is actually like this. All this semester we were studying different supervised learning techniques, right? We discussed classification tree, we discussed regression tree, simple linear regression, multiple linear regression, logistic regression. All of them basically are building the model to either predict a number, right, such as linear regression, or predict a classification, such as classification tree or logistic regression, right? So predict certain variable. Well, here is the thing, ladies and gentlemen. Let's say I have a gigantic file, all right? And file has many different records. Let's say 1 million records, okay? 1 with 6 zeros records. So let's say I want to predict sales based on advertising, or even better, let's say I want to predict the price of the car based on the mileage. Remember this example that we did in class, right? Now, I don't know if you heard, but different cars depreciate differently. So there are cars that basically lose value really slowly, okay? And there are cars that lose value really fast. So for example, I know if you buy BMW tends to be an expensive car, right? Probably, and I'm just guessing here, if you look at the same car 5 years later, just to see how much value it's lost, okay? The value lost by BMW will be much higher than the value lost by something less luxurious, such as Toyota Camry, for example, okay? So different cars depreciate differently, okay? So therefore, if I'm using, let's say this is my 1 million records about all of the cars, okay? If I'm using these million records in order to build my multiple regression, and this is my regression, right? Let me write it down here. Price of the vehicle is equal to intercept plus the slope multiplied by the mileage, right? That's what we used, okay? That's going to be building this regression based on all of my observations, right? All the cars in one pile. Toyotas in there, BMWs, Lexus in there, maybe a couple of, Teslas, who knows, right? So all the cars. So it's going to be just general regression. Well, instead of that, what I can do is I can run the clustering first. I can say, hey, how about this? We're going to look at different cars parameters, such as initial car value, okay? Extra options that the car has, like the class of the vehicle, right? Is it an SUV? Is it not the class, it's kind of type of the vehicle, right? Is it sedan, truck, or SUV? Then there is a class of the vehicle, right? Is it like economy class? Is it luxury vehicle? So different things about every car, right? And let's say that I'm running the clustering analysis on that, okay? And I'm going to tell the clustering method, hey, can you group my vehicles, all the million records, into, let's say, 5 different clusters, okay? And it will break it down for me. So here's my cluster 1, 2, 3, 4, and 5, okay? So in other words, my cluster 1 will contain vehicles that are somehow similar to each other, right? They're all luxurious, for example, and they all have high dollar value when purchased new, okay? And I have data for them separately. So what I can do is I can feed the model right here, okay? And it will be like price 1 equals to slope, intercept, mileage 1. So this is going to be the first model that applies only to luxury cars, right? Let's say this is going to be an economy class, like Toyota Corolla, Honda Civic, something like that, right? Relatively inexpensive cars that are supposed to be non-luxury at all, right? But supposed to have good gas mileage, right? Good maintainability, good quality built in, etc., etc., right? And I go ahead and fit the same model, but my parameters are going to be different, right? Price 2 is going to be another slope, it's going to be another intercept, and it's going to be, well, same mileage, right? So in other words, what I can do is group similar records together and then fit my models, which we'll learn, right, in this class, individually into every cluster. Who knows, maybe I'll get different models, and these models will perform better in general. They'll have higher R squared or lower mean standard error, okay? Because they are applied to a group of similar observations, okay? So in other words, clustering can be actually used as a first step for the supervised analysis. So first, I'm going to take gigantic data set and split it into similar observations, and then build the model for each one of them separately, hoping that each model will perform actually better than generalized model for all the records. Make sense? So in other words, clustering actually is a viable tool to use as a first step. So I'm not going to build just universal model of everything, right? I'm going to build the model just for luxury cars and then just for other types of cars. So based on how the clustering goes, okay? So today, ladies and gentlemen, we're going to discuss next step. One model actually, clustering model, which is called hierarchical clustering. But before we do that, let's have a little bit look, okay? In the previous class, we have discussed how can we define, let me find this slide, distance between two data points, right? And we said that distance can be defined in multiple different ways. For example, the one that you know from high school is called, what's it called? Straight line between 2 points. Starts with E. In the previous class we discussed it. It's the square root from blah, blah, blah. What's this distance called? This one right here. The answer is in front of you. Euclidean distance, right? And then we can have Manhattan distance. It's basically horizontal parts, right? All of my x1 minus x2 absolute value plus y1 minus y2 absolute value, okay? And we discussed correlation-based similarity. So there are multiple different ways how we can find distance between two different points, okay? But let's discuss how to find distance between two clusters. That's a little bit different assignment, right? Suppose I have a group of points right here and a group of points right here, okay? Clearly, this group is close together and this group is separate, kind of far away, but also close together, right? So how can I measure the distance between the two clusters of points? Well, as you probably guessed by now, there is more than one way to do that, right? Way number one, minimal distance, okay? Distance between two clusters is measured as 2 points that are closest together from cluster 1 and cluster 2. I'm going to call that a distance between two clusters. So you can clearly see that this point right here is close to this point, right? And therefore, I'm going to call that distance to be the distance between two clusters. Make sense? Yeah. How close are the closest points, right? One belonging to cluster 1, another to cluster 2. Here is quite opposite, right? Maximum distance. How close are the two clusters? I'm going to take the highest distance between the points. So this one right here, I'm going to say that, that's the distance between them. Okay, between cluster 1 and cluster 2. It's defined by points that are most far away. Here is another one that makes probably even more sense. What I can do is I can say, well, my cluster 1 contains how many points? 5, right? My cluster 2 contains 5 points. So how about this? I'm going to take point 1 from cluster 1 and measure all the distances to all points in another cluster, all 5 of them. And I can do the same thing. So overall, how many total distances do I have on this picture? 25, right? For each point I have 5 distances. 5 points, that gives you 25, right? So I can find all these 25 numbers and then just average them out. I'm going to say average distance between all points to all other points is going to define my distance between clusters. Make sense? Also makes sense, right? Or alternatively, I can go ahead and say, well, that's a lot of work, right? I mean, with 5 and 5 it works. How much computations do we need? Not a lot, right? 25 computations. But can you imagine if I have two clusters, each containing 500,000 points? Oh my God, right? That's computationally killing task, right? So therefore, it may not be very effective and efficient thing to do, right? So alternatively, here's what I can do. I can somehow find, and that is called, So in jump, let's go back, right? In jump, if you do it like that, if you go by the closest point, that method is called single. Okay, we're going to look at that actually later on today, hopefully, right? If you do it by the maximum distance, it's called complete, as you can see right here. Average is average, right? Average distance, and that one is called centroid. So what I'm doing really is I'm saying, hey, here is the bunch of points. All of them have coordinates, right? x1, x2, x3, etc. So I can find the center of this cluster. How many of you are right now in the management 410, supply chain management? Remember we discussed center of gravity? Yeah, center of gravity, right? So if I apply a certain formula, right, I can calculate the middle point sort of between these two, right? Between all of the points in my cluster 1 and all of the points in cluster 2. So that's my center of gravity, and that's my center of gravity. So these points represent the middle of each cluster, right? And then I'm going to say, well, distance between that point in red and that point is the distance between two clusters. So how far away are two centers located, okay? So that's called centroid. So there are multiple different ways how we can define distance between clusters. And by the way, each time when we use a different method, guess what happens with clustering? It will get different results, right? So therefore, there is more than one way to do clustering, and truly, there is no right way or wrong way. It's what you're getting as the output. That's what matters, right? Well, let me show you how the agglomerative clustering works. Okay, so agglomerative clustering, or one of the form of the hierarchical clustering, works like this. Okay, and I have actually, so this is a description really. Okay, but let me show you how it works. So before the class, I have prepared this picture. Hold on, I'm going to erase horizontal and vertical axis. All right, that part is, yeah, and that part. Okay, so suppose I have very simple case, these points, all right? Well, how many clusters do you think I have? Three, right? It looks like this is my cluster 1, this is my cluster 2, and this is my cluster 3, right? So here is basically how this method works. And let me kind of walk through that slowly, one by one, right? The start of the method is each point is the cluster of 1, right? An army of 1. Okay, so therefore, how many clusters do I have as my starting point? 11, right? 11 points, 11 clusters. So each point is a cluster of 1. Nobody told me that clusters cannot be just one point. They can, right? Okay, so what I'm going to do now is compute all the distances between all the points. So these points, all the distances, 3 of them, right? These points, that's from point 1 to all other points. That's from point 2 to all points, and that's from point 3. So all the distances I'm going to compute. Okay, same thing here. All the mutual distances, all right? Oh yeah, and also, by the way, I'm going to compute other distances as well. Okay, not just within clusters. I don't see clusters yet. Let's say I'm a program, right? I don't see this picture, okay? So therefore, I'm going to compute distances from each point to each other, right? This one. So all these distances, right? From this point to all of them. So that's a lot of distances, wouldn't you agree? Yeah, so let me erase all this stuff, right? So let's say I'm dealing with these points right now. And on each, this is an iterative process. It goes in cycles, it goes in circles. That's why it's called hierarchical, because it goes from highly disintegrated clusters. Each point is a cluster of 1, 2, all points are part of one single cluster, okay? So after I computed all the distances, I pick the one which is, what would you guess, highest or smallest? To group points together. Which points do I want to group? Close together or far away? Closest together, right? So out of these distances, I'm going to pick the smallest one, okay? And smallest one, well, at least to me, seems like this one right here, right? This one becomes my cluster of 2 points, okay? And the rest of the points are, by the way, still clusters of 1, okay? So here is my first iteration. Okay, I started with 11 clusters, so this is my cluster 1. How many clusters do I have now? I started with 11, right? Each point is a cluster. Now I have 10, right? Because 2 merged, and instead of 2, now I get 1. So it's old number minus 1, right? Now I have to find the center, right, of the cluster. Let's say, for example, I'm using centroid, just for simplicity, right? I'm using the centroid method. In other words, I find the center of gravity right here, okay? And now I calculate all the distances between points just like before. So these points, right? And these points, etc. But here I have a cluster 1, right, already. So therefore, really, these distances are the only ones that I'm calculating. So I'm losing the individual points, right? They're part of the cluster now, okay? So therefore, I have to compute the distance not to each point, but to the cluster center, okay? If I'm using centroid, right? And then, of course, I have all these distances, right? All these distances, etc. Right? But they are large, right? So we're not going to consider them. So for now. Okay, so let's say that my smallest distance is this one right here, okay? This one right here. So therefore, what happens is, now I say, these 3 points, they form next cluster, right? On the next, it's still C1. And that's the center of it, okay? That's the center of my cluster. So now I'm dealing with 9 clusters, right? You see what's going on? On each iteration, I'm losing 1 cluster, right? It joins some other thing, right? So my clusters are becoming bigger, and number of clusters goes down, right? Okay, cool. So next iteration, I have to again compute the distances, but now it's the distance from that point to the cluster center, right here. That's an ugly distance, hold on. Oh God. So here's my cluster, and that's the distance, right? And then I compute all the other distances. So from the center over here, right? From the center over here, from these points, right? And then I pick the smallest one, right? So I'm going to erase the large ones. And let's say that this time around, the smallest one is right here, this one, okay? So now these 2 points join together. That becomes my cluster number 2. And again, what I do is I find the center, right? And on the next iteration, what I do is, now instead of these 2 points, I'm using the cluster center, right? So I have these distances, right? And then I have distances from these points to the cluster center, and to these points individually, etc., right? All of them. Okay, so I'm looking again for the lowest distance, right? So let me erase the big stuff, okay? Let's say that next time around, here is my lowest distance, right here. That becomes my cluster number 3. And of course, here is the center, okay? So as I go, my clusters, like I said, aggregate, right? So that's why it's called agglomerative procedure. So I start with completely disaggregated field, right? Each cluster is just 1 point. Then I kind of merge them together, right? So next iteration, let's say that this is my winner right here, this distance, okay? So these clusters join together, happy family, okay? And here is the center of the cluster. All right, next iteration, here is my new distance, right? And when I measure distances, let's say that this one wins, this one right here, okay? So these points form a cluster. And now I have to recompute the center, right? The center is going to be somewhere over here. Now I have actually a much simplified situation, right? Because really, here is one only distance that's remaining in this group of points. And of course, what I need to measure is distances between the cluster points as well, right? Cluster centers. But they're large, right? Right now, they're all large, they're all far away. So I'm going to do that. So out of these 2 remaining distances, let's say this one is winner. So therefore, these points join together, and here is the new center, okay? Now I have only what? 4 clusters, right? I have C1, I have C2, I have C3, and that is still a cluster, right? 1 point out there, okay? So obviously, which distance is going to be the shortest? This one, right? Right here. So therefore, these points join together, right? And here is my center of clusters. Does the procedure stop here? No, it keeps going, right? If I want to take it a step further, I absolutely can. Now, what are my distances now? What am I measuring distances between? Between the clusters, centroids, right? Because really each cluster is characterized by its center, because I chose centroid to begin with. So therefore, how many distances do I deal with right now? 3, right? 3 clusters, there are 3 distances between them. That's 1, that's 2, and that's 3. Which one is lowest? This one probably, right? So on the next iteration, what will happen is, instead of clusters 1 and clusters 2, I'm going to have the joint cluster, well, still number 1, right? And the center probably is going to be somewhere over here, right? And on the last iteration, guess what will happen? I have 2 clusters. They all merge together, right? So therefore, I don't have C1 and C2 anymore. I have one big fat cluster with the center somewhere over here, okay? So that's basically how the procedure works, okay? So I start with all points by themselves, and then I merge closest points together and find the center of cluster, or whatever measure I'm using, right? And then I keep merging points and clusters. Finally, the last thing that I will see is one single big cluster, okay? Well, do you want to do an example just to see how it works? Let's do it. Remember in the previous class we discussed utilities, right? The file. So go ahead and open it up. Fire up jump. Okay? And in jump you will find the file utilities, right? That's the one that we used. Remember what we did back then was basically we said, and it's kind of going to be interesting actual exercise now that I think about that. Remember when we, let's do it actually, like this. Let's do the graphing again, right? Like what we did in the previous class. So go to the graph builder, right? And what did we plot? We plot only 2 variables against each other, right? Because we're 3-dimensional humans who understand only 2-dimensional plots. We said, let's pick one variable and another variable and do the scatter plot. What was that? Fuel cost, horizontally, I believe. And vertically we had sales, something like that, right? And then let's just get the scatter plot, like this. So when we looked at the picture, what did we find? We said, these 4 points right here, it looks like they're close together, right? They form their own cluster. So that's low fuel cost, high sales, right? And then we said, these points in another corner, they apparently form their own cluster, different one, right? That's high fuel cost, low sales companies, right? Not good. And these points right here, they form their own cluster, or at least it seems like this, right? Kind of low fuel cost, low sales. Okay, so let's go ahead and do the clustering with this simple data set, only 12 observations, right? So I'm going to go ahead and put that down, right? Okay, and can you guess how do I find clustering in JUMP? If I go to Analyze menu, do you see where I should go next? Right there, right? Clustering. And what we discussed was hierarchical, right? Moreover, agglomerative. By the way, agglomerative clustering works kind of agglomerating points, right? We start with all points by themselves, then we build bigger and bigger clusters until we end up with one, right? There is a reverse clustering method. When you start with one big fat cluster and keep splitting the cluster, kind of, it works in the opposite direction, right? We're not going to discuss that, but just so that you know, there is another way to do it. Okay, so let's go with hierarchical clustering, okay? So it says, what variables do you want to take into the account? In other words, remember we discussed that. There is not a single target, right? This is an unsupervised method. I'm not predicting sales. I'm not predicting fuel costs. I'm not predicting classifications, right? I'm really using all of my columns as a variable, as one of the measurements, how I define points close together or far away, right? So therefore, I'm not going to put just one single column in this area. I'm going to put everything that I decided to use. What do you think company name? Will it help me to this? No, probably not, right? Company name is just made up name, right? So I want to cluster things based on numbers, right? Based on financial measurements, operational costs, and stuff like that. So I'm going to put all of my columns except company name as the fields that I'm going to use to cluster things, right? Okay, and look at that. Here, my choice is hierarchical, which we just discussed, or k-means, which we didn't discuss yet. We'll discuss it next week. Okay, or that one we're not going to discuss at all. So let's use hierarchical, and look at that. I can use average. Remember we discussed different things, right? Four different methods, how you measure distances between clusters, right? I can use, remember, what if I used closest points? How was it called in JUMP? Like minimal distance between 2 points. I believe it was single, right? Single. What if it's maximum distance? Complete. Then average is all distances averaged out, right? And that is between the centers, right? What we just did in this illustration, in this picture, right, was basically based on centroid, right, clustering. So let's go ahead and use centroid, okay? All right, and then I'm going to go ahead and click OK, and here is the something called dendrogram. Dendrogram probably because it looks like a tree, right, kind of branching out tree, right? So, can you see these two diamonds, black diamonds right there? That is actually a line between them. There is a line between them, so you can drag them, okay, in or out, right? And here is a number of clusters on each iteration, right? So we start with all clusters completely disconnected, right? Completely disaggregated. So here is your, how many clusters, how many points we get? 22, right? 22 points, okay? And then as I go, and I can also, I believe, do you see them in color, by the way? Or is it just me? You don't see them in color? Okay, here's an option, right? Color clusters, right there. So from the red triangle, if you go ahead and say color clusters, then they should be highlighted, oopsie, in different colors, okay? So there it goes, right? So if I'm at the end, right? If I'm at the end of my procedure, then I have a cluster of 1. They're all colored the same, right? All points are together. And then I can kind of move it back. So at that point, clustering is done, right? But question that you may ask, what do you think is the obvious question? Like we started with 2 clusters, we ended up with 1, right? So what's the outcome of this procedure, right? Is it 1 or is it 3 clusters? Is it 5? Where do we stop, right? And the answer is, there is no answer. There is no right or wrong answer, okay? So if, for example, I want just to separate, it's up to me right now to decide, okay? What happens if I keep it like that? If it's all cluster of 1, is it a good clustering technique? Basically declaring that here's my data, the whole data set that I have is cluster of 1, just 1 single cluster. It doesn't really add any value, right? Obvious, right? I group them together, that's 1 cluster, duh, right? Does it help if I use every point as a cluster of itself? Completely disaggregated. It's probably another extreme, right? I don't want that, okay? So I want to end up with reasonable number of clusters, okay? If I have too few clusters, then probably I'm going to end up with some mixed data, right? Mixture of different patterns, basically. And I don't want that. If I'm going to go with too many clusters, then some of them may be hard to distinguish, right? Because points are so close, but still I had to have a lot of clusters, so therefore really they're close, okay? So it's almost the same 1 cluster. So there has to be a balance, okay, reasonable balance. So I'd say at that point in time, it's your call as a manager, right? You're going to say, well, I don't want to have 2 clusters, but I don't want to have 11, so let's pick a reasonable number. Let's say I want to split all these points into the clusters into 3 clusters, right? Let's say. Well, and let's actually see how it works. So what I'm going to do is drag the line when I see 3 clusters right there, right? And look at that. It's actually not very interesting, right, case, because what do we see when there are 3 clusters? There are 2 companies that kind of stand out all by themselves up until very end, right? You see that? We're kind of joining clusters together, right? So all this drama was happening right here. And company New York, right? And company San Diego were the 2 diehards, right? That basically survived as the single point until the very end, right? So that's not very interesting, probably. Okay, but yeah, that's basically how the hierarchical procedure works. You know what? Let's just for the heck of it, we used all of our 8 columns, right, as the measure of the clustering thingy, right? Clusterness, or however you call it. Remember when we had a 2-dimensional analysis, we kind of said these points are grouped together, cluster of 1, right? These points are grouped together, and these points are grouped together, okay? So maybe, let's just see. Maybe I'm wrong, but let's see. What if I use only these 2 columns as my way of clustering, right? Only cost, or fuel cost, and only sales. will the algorithm pick up on that pattern, right? It's interesting. We can see visually how clusters are kind of formed, right? But let's see what algorithm will tell us. So let's go back to the clustering thingy, right? And let's close it out, actually. And let's go through analyze, clustering, hierarchical clustering, and let's do the two that we have selected, right? Maybe nothing will come out of it, who knows? So which ones did I use? Sales, right? And what else? Fuel cost, okay. All right. And I'm going to use average, right? No, centroid. Let's use centroid. Okay, so let's click OKZ. Here is my clustering thingy, right? And I want to see if my three clusters that I kind of visually looked up on the scatter plot are the same as the ones that as the algorithm picked up for me, right? So that's 4, right? And that's 3. Okay, so it doesn't look the same, does it? No, because really there are 2 companies, I believe, right? No, hold on. That's cluster number 1, right? That's cluster number 2, and that's cluster number 3. Is that correct? So these companies right here, right? They form their own cluster, agree? These companies right here. And these companies form their own cluster, and these companies form their own cluster. So it's kind of weird a little bit how it does, right? So let's highlight them. Let's highlight all these things, right? Okay, and hopefully, so this is my cluster number 1, right? Because it joined the game only at the very last step, right? When I was joining things. This is my cluster number 1, that is my cluster number 2, and that is my cluster number 3. Well, let's see if on the chart, if that is the same thing as was picked up by my graph, right? Ah, look at that! Isn't that amazing? You see that? That's precisely what the algorithm did for me, right? First, I kind of eyeballed this picture, right? I said, yeah, looks like they're all in the same corner, right? They're close together. And now that I have, I've selected what appears to be one of my clusters, right? And that's exactly what algorithm actually showed up, that these points are close together. That's amazing, right? Well, let's take a look at another cluster. These 4 points, right? It looks like they also stand up until the very end, right? And only then, after that, they join, and then there is another join, right? So it's one of the 3 clusters that survives almost until the very end, right? Let's see where this, look at that. These points are my low fuel cost, high sales. So algorithm picked up exactly what I picked up as a human being by looking at the picture. Is that cool or what? Very cool, right? And let's take a look at the last one. Well, last one obviously is going to be the corner cluster, right? Low cost, low sales. But let's kind of visually confirm that. Is there a way how I can select them all? Typically, you like hold control down and it selects. No, it doesn't. Okay, I have to do them one by one. All right, so this is my cluster number 3. All right, and right here is my cluster number 3. How about that? Isn't that surprising or what? Okay, so another kind of word of wisdom, I guess, is when you are using, let's go back to clustering, okay, analyze, clustering, hierarchical. So we looked at different, that there are 4 different ways, right, how you can define distance between clusters. It can be the smallest distance, single, the highest distance, which is complete. I don't know why they call it like that, quite honestly. I would just call it minimum and maximum, but they call it different, right? And then average and centroid. What happens is, typically, if you use the average method or centroid method, your clusters tend to be kind of round shape, okay? So circles. That's what we expect from clusters to look like, right? Points that are close together, they kind of form their small little bubble, okay? So that's what happens if you're using average method of defining distance between clusters and centroid method. If you have clusters that look like chain, you know, something like this, for example, let me bring up the, something like this. Let's say I have a bunch of points here, and I have a bunch of points here, and I have a bunch of points here. So basically, they look like links of chain, right? My 3 clusters. So typically what I want to do is kind of cluster together the points which have lowest distance between them, closest distance between them, right? So therefore, all points which are in this group, so the cluster will grow basically. In other words, if I use the lowest point, right, or what the jump calls, what's it called, single, right, single method, this shortest distance between the cluster and another cluster. So the way basically how this cluster works is, let's say I start with like these points which are close together, right? So let's say it picked up this group of points, okay? Next one is going to connect with the point which is closest to one of these guys, right? Because it uses the smallest distance, right? And that obviously is going to be this point right here. So the cluster will grow by basically merging with the next closest point, okay? So therefore, if you have points which are grouped like that, then probably if you use the minimum distance, okay, then you will end up with clusters that kind of look a little bit like links of the chain, right? So in this case, minimal distance would be your weapon of choice, okay? All right, so that about covers it, ladies and gentlemen. So now we know how to do clustering using the hierarchical agglomerative technique, okay? So next week we're going to discuss k-means, and what's the downside also. I believe we're out of time, right? We're going to also discuss what's the downside of this method. I mean, it's pretty cool, right? We just saw how we can cluster, and it gives us the exact same answer as human eye, right? By just looking at the picture and saying, yep, these are the three areas. So what's the downside? In spite of the fact that this method is really cool and powerful, as you can see, it comes at a cost, at a computational cost, okay? So sometimes, if you have especially a large data set, it's not going to work well, okay? All right, that's it for today.